there's this length formula. This is a length formula. It says 1 by v minus 1 by u is 1 by f. It tells you that the v is the image distance, u is the object distance, and f is the focal length. He says all these are connected. That means where you place the object decides where the image distance will come, where the image will form, and also it depends on the focal length of the lens. So essentially what it, if you see this pattern, if you if you see this pattern, what are you seeing? You are seeing one, that in this case the object is at infinity, like sun rays coming, and they get focused on the focal length. Okay, so the object is at infinity, the image, that means vu, the object distance is infinity, and v is f. And that comes from the formula 1 by v minus 1 by u is equal to 1 by f. If I make u as infinity, obviously this will become 0 and v will become equal to f. So that's what happens. Now, then what happens is if you come closer, now you're coming from infinity, the object is at infinity. Now the object is beyond the center of curvature or the double the focal length. In that case, what you observe, you have come closer, this goes further, and two, the it kinds of enlarge is now enlarging, though it's still diminished, is the size is less than the object size, but it is now increasing in size. So as you're coming closer, as you're coming closer, the image distance is increasing and the size is also increasing, but it's still diminished. Now you come at 2f, you get the same size, but it will be it will now be equal to this. So there's no magnification. So, and it will be exactly at the same location, this distance and this distance. Now, this is what the table is saying. The table says that when the object is at infinity, the image is at the focus, it is highly diminished point size and it is real and inverted. Now, why is it real? Because you can get it on screen. Inverted, so it's so small, but it is inverted. Real is always inverted. Then you come closer, but still you are beyond 2f. You get a you get a image between 2f and I mean you are here between 2f and f. So if you are you get between f and 2f, and it is still diminished, but it's now increasing, is real and standard. Then you come at 2f. At 2f, you get the same at the same size. And so now this, there are three images, each has a role. This you can use in telescopes because basically the stars are at infinity and you're getting an image. Now, what is a telescope? It's like the stars are at infinity. You create an image at the focus of this lens, the objective lens is an objective, and then the eyepiece takes the image uh, for at focus and makes the final object at focus, because this image is the object for the eyepiece, and it makes the final image at infinity. The eye sees it at infinity. Now, if you see this, this is this case that the object is at focus and at infinity, and it's infinitely large and highly so. So you can see something which is very small, stars. So this is the objective of the telescope. This is the eyepiece of the telescope. So this is how you are using two images in inside the telescope. Then this is at 2f same size. This is generally used in a photocopier, and this is beyond 2f is generally what a normal camera or an eye sees. The eye and the camera sees this. Now you might wonder, we don't get an inverted image. The brain flips it. The retina sees an inverted image, the camera flips it, and the brain flips it. So this is because generally we see objects which are beyond 2f, and this comes inside your eye. Okay, and so these three situations I have told you. Now comes the other two situations. The other two is uh, We have now brought it closer. This is you have increased the size. This is being increasing all the time, and it's also going farther away from the lens, the image distance, and it's becoming bigger. Now, this bigger thing is in projector screens on projectors you have those big movies shown on projectors. You make it big, and this is or photograph enlarging, and then this was the photocopier, and this is the telescope, this thing, and this is a normal magnifying glass. Now, there's a difference. The magnifying glass can be used here also. This is also a magnifying glass. You are bringing sun rays and concentrating it and burning paper. You are concentrating here, you got infinity, but object at infinity, and the image at focus, and you concentrate, you burn paper. Here it's slightly different. You have still the magnifying glass. Now the object is not at infinity. The object is between it's not even at focus this time. It is between the focus and this, and you get an erect image. And this is what you normally do in a magnifying glass. What you do is you see a magnifying glass to increase the size of text. So this is the text. This letter AB, this AB is the text. What you do it, you bring your magnifying close to the paper. This is so close that the text should come between the focal length of the magnifying glass, and then it appears magnified. Only then. Otherwise, it kind of appears as a small or distorted or upside down or something. So here it becomes. So this will only happen if you bring the magnifying glass very close to the paper. That means you have brought the text within the focal length. So these are the uh, i- and you use this here or even in microscopes. Like I've told you these in microscopes also we use. So this is a microscope. You have two lenses, an objective and eyepiece. Uh, uh, Here you place the object. This is not the telescopes. Otherwise, the rays would be coming from infinity. You have placed the object at some position which is beyond the f, and then it creates the bigger, and then you place this within the f. I mean f of this. So you get a virtual. This is that situation, placing the object. So the image first is the object, then you get that image of this that serves as the object of this, and you are basically the object is within the focus, so it is creating a erect image of the. So they use all these combination of lenses. That's all these six images, six these these six they will combine in different ways, whether it's telescope, microscope, camera, wherever.